Dear students, in this lecture, we are going to discuss about what is reactance, impedance, what are the types of reactances, as well as admittance. Admittance means it is the combination of conductance and susceptance. These parameters we are going to study about in this lecture. First of all, what is reactance? Reactance is nothing but it is opposition to flow of alternating current due to the capacitance as well as inductance. Basically, it is represented by denoted by X and the form of opposition that electronic components exhibit to the passage of alternating current because of capacitance or inductance. So it is measured by in ohms, whereas the resistance is also measured in ohms, whereas reactance is the denoted by X and it is opposition to flow of alternating current due to the capacitance or inductance. It is measured by X and measured in ohms. There are two types of reactances, namely inductive reactance XL as well as capacitive reactance XC. First of all, we will see about inductive reactance XL. Inductive reactance, it is defined as the measure of the opposition to alternating current by the inductor. It is nothing but it is the resistance of the inductor, whereas resistance of the resistor is denoted by R and the resistance of the inductor is denoted by XL is nothing but inductive reactance. The measure of the opposition to alternating current by the inductor is nothing but inductive reactance. The unit of inductive reactance is ohms like resistance and denoted by XL. The XL form XL equals to 2 pi FL. As we seen in pure inductor excited by AC supply in previous lecture, already we have seen XL equals to 2 pi FL ohms, where XL is the inductive reactance, L is the inductance of the inductor, F is the frequency of the alternating current. Then capacitive reactance. What is capacitive reactance? It is denoted by XC and defined as the measure of the opposition to alternating current by the capacitor is called as capacitive reactance. The unit of capacitive reactance is ohms like resistance and the symbol of the capacitive reactance is XC. As already we have seen in pure capacitor excited by AC supply. So Xc equals to 1 by 2 pi Fc ohms, where Xc is the capacitive reactance, F is the frequency of AC supply and C is the capacitance. So in this way, the reactances are two types, inductive reactance and capacitive reactance, XL and XC. Then we will go to impedance. What is impedance? Impedance is an element that opposition to flow of alternating current in AC circuits. So impedance is the element that opposes the flow of current in AC circuits. It is also defined as ratio of voltage to current in AC circuits. Impedance also defined as ratio of voltage to current, or else it is also combination of resistance and reactance. Another definition, we can also define impedance is the combination of resistance and reactance. So it is denoted by letter Z and measured in ohms. The impedance consists of two parts, namely real part and imaginary part. So impedance is also defined as combination of resistance and reactance. Resistance is the real term, whereas reactance X is the imaginary term. So impedance can be represented in two ways. Impedance can be represented in two ways. One is the rectangular form, another one is the polar form. Rectangular form, impedance can be represented in R plus JX. X may be two types, whether XL or XC, based upon the depending upon the circuit. If circuit contains L means XL, if circuit contains C means XC. If circuit contains both L and C means XL as well as XC, both will exit. So that Z equals to R plus JX ohms. This is the rectangular form. And R is the resistance real term, X is the reactance term. J is nothing but the imaginary term. J is always placed in front of imaginary term. So next one, polar form. So impedance can be also represented in polar form. Polar form, impedance is represented in Z. Impedance equals to magnitude of impedance Z at an angle phi or theta in ohms. So the magnitude can be represented by using impedance triangle. Z equals to square root of R square. Later we will see impedance from the impedance triangle, square root of R square plus X square. In this way magnitude will be find out. and theta or phi equals to tan inverse x by r, tan inverse imaginary term by real term. So tan inverse x by r imaginary term by real term, phase angle. And impedance triangle. So impedance also represented in rectangular form, r plus jx. Impedance is the triangle, right angle triangle whose base perpendicular and hypotenuse represents the resistance, reactance, impedance respectively. It is a geometrical representation of circuit impedance. So z equals to r plus jx. R is the reference real term, always taken as reference vector. And reactance contains imaginary term j. J is nothing but 1 at an angle 90 degrees. J is nothing but 90 degrees. So reactance is the perpendicular to real term resistance. So the combination of resistance, reactance will give the impedance. So this z hypotenuse will give the impedance. This is the base r and this is the perpendicular to base reactance. So z equals to square root of, as per Pythagoras formula, square root of r square plus x square. And tan phi equals to opposite side by adjacent side, x by r. So phi equals to tan inverse x by r. In this way we will calculate the magnitude as well as phase angle. So from the above triangle, from OBA, we can calculate the magnitude and phase angle by using Pythagoras formula. So OB square plus OA square, hypotenuse square equals to side square plus side square. That equals to z square equals to r square plus x square. Z equals to square root of r square plus x square. And tan phi equals to x by r, phi equals to r theta equals to x by tan inverse x by r. In this way, we will calculate the magnitude as well as phase angle. Let us see some example. The impedance of the particular circuit is given as Z equals to 8 plus J6. The magnitude of the impedance and power factor can be calculated as follows. The magnitude of the impedance and power factor. So impedance, as we seen just now, we have seen Z equals to, from impedance triangle, R equals to resistance is the real term, J 6 ohms is the imaginary term, reactance. Square root of 8 square plus 6 square will give the 10 ohms magnitude, and phase angle will be calculated. Phi equals to tan inverse imaginary term by real term. Tan inverse 6 by 8. Tan inverse 6 by 8. The angle will be obtained. By using cos phi, cos of this angle will give the power factor, or else cos phi equals to adjacent side by hypotenuse. In this way also we can calculate r by z, 8 by 10, 0.8 power factor. So in this way we will calculate the magnitude as well as power factor, or theta also, phase angle also we will calculate. What is the importance of J? What is the importance of J? That means, as already I told you, J is the imaginary term. J is always placed in front of imaginary term. Here we will see. So J is the most important operator in electrical engineering. J is the most important operator in electrical engineering. It is a imaginary term, and distinguished. It is used to distinguish or discriminate the imaginary term from the real term. Real term is the resistance. Imaginary term is the imaginary or fictitious term is the reactance. So J is most commonly important term used in electrical engineering. It is denoted by J and always placed in front of imaginary term to discriminate the distinguish from the real term. Here we know that this is the 0 degrees, this is the 90 degrees, the here 180 degrees, here 270 degrees. Suppose I kept one at 0 or 360 degrees. if any time varying quantity is multiplied by j, that parameter, that time varying quantity will be advanced by 90 degrees. If any time varying quantity is multiplied by j, that will be advanced or lead by 90 degrees. So here, initially I kept 180 here. I want to move the 90 degrees from this way. So 1 is multiplied by 90 degrees means j equals to 90 degrees. So here 90 degrees will come. 1 into j equals to, as we know that already we have studied in intermediate level, j there I we have studied I equals to square root of minus 1. Here j we will study j equals to square root of minus 1. So if you turn the 90 degrees, 1 into 90. So 90 is nothing but j equals to 90 degrees. Then afterwards further I want to move 90 degrees from year to year. 90 degrees here, j is already placed. 90 means j into j square. So j square will come here. J square equals to square root of minus 1 whole square. J square equals to minus 1. Similarly, I want to move further one more 90 degrees here, from year to year. Here j square is there. Here j square into j. 90 degrees means j. Any time varying quantity is multiplied by j, that signal will advance by 90 degrees or lead by 90 degrees. Here j cube will be come. So j cube equals to j square into j minus j. So here finally I want to move the another 90 degrees. So here j cube is there. J cube into j power 4, j square into j. So 1 will come. So in this way, any time varying quantity is multiplied by j, that parameter will advance by 90 degrees or lead by 90 degrees. This is the importance of j. So that j is always placed in front of imaginary term to distinguish from the real term. So thank you.